Hello everyone, it's Krish and today talking about Uber Analytics. So I have made a presentation and working on it shortly. So this is Uber real-time analytics with Apache Spark and Kafka. So a big data case study on how Uber processes trillions of events daily to power split seconds decision across 65 countries and 600 cities. So this is case study 2. So the need of speed. Uber's marketplace is live and constantly moving. Traditional batch processing, updating data overnight is completely useless for its needs. So it uses live maps, real-time ETNs, search pricing. Under live maps, cars must appear moving on the map instantly when the user opens the app. Real-time ETN. Routes and available arrival times must be calculated immediately using current traffic. Search pricing. Prices must adapt in seconds when demand spikes at concerts at airports. The architecture of Kafka plus Spark to handle GPS coordinates, traffic speeds, payments, and app interactions. Uber built a real-time streaming platform to on to open source technologies. Together, they process trillions of messages and petabytes of data. Milliseconds latency. Apache Kafka data ingestion, the central nervous system. Apache Spark data processing, the analytical brain. The ingestion layer. Apache Kafka. Kafka is Uber's central nervous system, distributed event streaming platform handling high throughput, low latency. Uber runs one of the largest Kafka developments in the world. Producers. Driver and rider phones sends GPS requests and payments. So that there are three data flows according to it. Producers, consumers, and topics. And producers, as I've explained, drivers and riders phone sends GPS requests, payments. Under consumers, pricing, engine, map, service, and other apps subscriber. Topics, channels. The driver, location, trip events, payment requests. The processing layer of the Apache Spark by Spark. Unlike other systems that write to disk at every step, Spark processes in DRAM, making it up to 100% faster for real-time workloads. Spark streaming micro batching. Spark streaming chops Kafka continuous data flow into small micro batches and applies complex algorithms instantly and detecting traffic jams by averaging drives speeds on a highway segment. MPavel predicts the future. Uber's machine learning model run fly to predict where demand will spike in the next 15 minutes, not just reporting what's happening but anticipating what comes next. What are the business impact and use cases on Uber? So there are three types: dynamic search pricing, accurate ET and routing, and fraud detection. In dynamic search pricing, Spark compares ride request versus available driver per geofence in real-time location, auto-triggering prices multipliers to balance supply and demand. Spark processes GPS traces and all activities Uber vehicles to build a proprietary traffic map or produce granular than public maps. Fraud detection, pattern matching, flags, impossible scenarios. Example: same card used in London and New York within 5 minutes. Blocking transactions before completion. Conclusion. Key takeaway. Uber's Kafka plus Spark platform transformed a logistical nightmare into a seamless experience. Kafka provides a robust pipeline to ingest trillions of daily events. Spark delivers in-memory speed to analyze them instantly. Together, they optimize routes, balance supply and demand, and prevent fraud. In the on-demand economy, speed of data processing is the ultimate competitive advantage. So now I'll be telling about showing my working case in the VS Code. I show my code and how it has affected it. So this is the Uber case study code, and this CSV file I show you. So this is the output which I've gotten from my code. This is operational summary, rides processed, cumulative revenue, distance traveled, aggregated distance. These are the current value. And city-wise ride analytics is Miami, Phoenix, Chicago, Seattle. There's total rides, average fare, total revenue, distance, average duration minutes, average search, average minute. So all of this is stored in our CSV data sheet from which I've gotten from Uber. I'll show it to you. So gateway, security and transaction analysis. These are the payment methods. There are three: credit card, digital wallet, and cash. So more people have paid in using credit card, lesser in digital wallet, and lesser in cash. So these are the total volume, fraud cases, success rates, average transaction, risk score. These are the route optimization, intelligence, and distance performance. So distance brackets this is medium, long, and Excel. Route count, utilization, average time, revenue, average rating, and eco score. This is the table 4 of service quality assurance and customer satisfaction dashboard. This is premium and excellent for the rating tier. Discount, this percentage is average revenue and repeat. And this is the data which I have obtained from the Kafka website about Uber. So thank you guys for listening to case study on analytics. Thank you.